How did the punch bag hit the box hat? Where did it get so much force? The punch bag exerted the same force on the box hat as the box hat exerted on it. That is, it was reacting to the boxer's action. This was an instance of Newton's third law of motion in action. The third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first.
तो क्लास न्यूटन्स थर्ड लॉ के अकॉर्डिंग जब एक ऑब्जेक्ट दूसरे ऑब्जेक्ट पर फोर्स एक्सर्ट करता है तो दूसरा ऑब्जेक्ट भी फर्स्ट पर फोर्स एक्सर्ट करेगा. ठीक है. व्हेन एन ऑब्जेक्ट एक्सर्ट्स अ फोर्स ऑन अनदर ऑब्जेक्ट, the second object instantaneously exerts a force back on the first. अगर first वाला second पर force exert करेगा तो second वाला भी ultimately first वाले पर force exert करेगा. आपने यहाँ पर देखा कि एक boy था वो punch bag पर force exert कर रहा था, तो क्या हुआ ultimately जो punch bag था उसका भी force boy पर exert हुआ.
These forces are always equal in magnitude, but opposite in direction.
तो you have seen ये जो forces थे equal की magnitude में, जितने magnitude से boy ने bag को hit करा उतने ही magnitude से जो punch bag था वो boy पर force exert करेगा. But the forces are opposite in direction. ठीक है. ये देखो boy इस direction में force exert कर रहा है और punch bag इस डायरेक्शन में फोर्स एक्सर्ट करेगा. इज इट क्लियर? देखो boy ने इस डायरेक्शन में फोर्स एक्सर्ट करा और पंच बैग ने इस डायरेक्शन में फोर्स एक्सर्ट करा. इज इट क्लियर? अगर दोनों सेम डायरेक्शन में कर रहे होते तो boy इधर करता तो पंच बैग भी इधर जाता. ठीक है. बट दोनों क्या करेंगे? ऑपोजिट डायरेक्शन में फोर्स एक्सर्ट होगा, बट द फोर्स विल बी इक्वल इन मैग्नीट्यूड. फोर्स A विल बी इक्वल टू फोर्स B. जो फोर्स B था उसी मैग्नीट्यूड का फोर्स A था. क्लियर हो गया आपको?
Let's conduct an experiment to prove this law. Two spring balances are connected together. The fixed end of balance B attached to a rigid support, such as a wall. We apply a force through the free end of spring balance A. Observe the readings on the scales of both the spring balances. What do you see? Both readings are the same. This is because the force exerted by spring balance A on balance B is equal but opposite in direction to the force exerted by the balance B on balance A. Thus, balance A acts on balance B, and balance B reacts to the force exerted by balance A. In other words, Newton's third law of motion can also be stated thus. To every action, there is an equal and opposite reaction. To further understand this law, let's take a look at a couple of scenarios where opposing forces can be seen. A heavy object stands on the floor. Which are the forces acting on the heavy object? object is pulled down by the earth with a force mg. It does not move inside the earth because the floor is exerting an equal and opposite force on it. Do you think this is an example of Newton's third law? The answer is no. This is an example of equilibrium between forces. Two equal and opposite forces are acting on the same object, cancelling each other out. That's why no acceleration or motion is seen. Let's consider the firing of a gun. The force of the gas produced by burning gunpowder hurls out the bullet. The gunman experiences recoil. This is an example of Newton's third law in action. By Newton's law, the gun itself recoils backwards. The action is on the part of the bullet, and the reaction comes from the gun. That is, two different objects are involved.
तो now it is clear to you कि जो third law of motion है, action और reaction अलग-अलग objects पर होते हैं.
Action refers to the force exerted and should not be confused with velocity.
Here object 1 was bullet and object 2 was gun.
Hence, it is important to remember that Newton's third law always involves more than one object.
So it is very important statement that Newton's third law of motion will always involve more than one object. Is it clear, class?
The third law of motion can be seen in action in a very common activity that all of us perform in our everyday life. Can you guess what activity this is? Walking. Suppose you are standing still and want to start walking on a road. That means you need to accelerate. As you know from the second law of motion, acceleration of an object requires a force. Where does the force required to walk come from? When you take a step forward on the road below is pushed backward by your foot. The road reacts by pushing your foot forward with equal force. Based on this, can you explain why a runner is unable to run on a slippery road? Try kicking a slippery road. A runner requires the kick from the ground to push him forward. To get this reaction, he needs to perform the action of kicking the road back. However, without sufficient friction to gain traction on the ground, it is difficult to kick it without skidding off. And no action means no reaction from the road. Let's look at another example. Oops, why did that happen? The boat seemed to move away from the dock magically. Well, when the man tried to jump forward out of the boat, he applied a force onto the boat. The boat reacted by moving backwards with the same amount of force. That's why, before jumping from a boat to the dock, we should tie the boat to the dock first. Also, make sure you grab a handhold on the dock before jumping. The launch of a rocket is also based on Newton's third law. this balloon. In this balloon, air rushes out of the balloon downwards. This air exerts an equal and opposite force on the balloon, pushing it upwards. In a rocket, gases are produced due to internal combustion. They come out and move backwards. In doing so, they exert an equal and opposite force on the rocket, making it move forward. The jet plane also works on this principle. Finally, how about gravitational force? Every falling body is attracted to Earth owing to gravitational force. So, doesn't this law apply to them? A falling body also applies a force of attraction onto the Earth, trying to change its velocity. However, since the mass of the Earth is very large compared to that of a typical falling body, the change in velocity of the Earth is not noticeable.
Okay class, see here, Newton's third law of motion states that every action has an equal and opposite reaction. Newton's third law क्या कहता है कि हर एक्शन का एक इक्वल और ऑपोजिट रिएक्शन होता है. फोर्सेस शुड एक्ट ऑन डिफरेंट बॉडीज. जो फोर्स होता है वो अलग अलग बॉडीज पर एक्ट करता है. ठीक है. उसके बाद आता है आपका मोमेंटम. सबसे पहले क्लास मुझे मोमेंटम का फॉर्मूला बताओ. याद है आप सबको मोमेंटम का फॉर्मूला क्या होता है? P इक्वल्स टू mv. इज इट क्लियर? आप लोगों को SI यूनिट्स भी पता होगी मोमेंटम की. मास की क्या होती है? किलोग्राम. वेलोसिटी की होती है मीटर पर सेकेंड. ठीक है, सबको मोमेंटम पता है क्या होता है?
An efficient fielder can stop a cricket ball with his hands and prevent the batsman from scoring a boundary. Can anyone stop a fast car that way? When a man runs into a parked car, he won't be much affected. But if the car is moving, even at a moderate speed, he is likely to be seriously injured. The force of a moving car in collision with the man is likely to be severe. When the man runs into the parked car, the impact is small because the man's mass is smaller than that of the car. We need less force to stop a moving ball because its size is smaller.
So is it clear? A smaller mass has a smaller impact. Smaller mass has a smaller impact.
We require more force to stop a moving car
और
because
जितना
its
ज़्यादा
size
मास
is
होगा
greater.
उतना ज़्यादा इम्पैक्ट होगा.
Let's compare a flying cricket ball and a bullet fired from a gun. Can we expect the same impact in both these cases? No. Though the bullet is smaller than the cricket ball, its speed will kill a person when it is fired from the gun. But the cricket ball does not hurt so much. What do you infer? The mass alone does not give us an idea of the magnitude of force required. Speed is also necessary to explain the force. Momentum is a physical quantity. It is defined as the mass in motion. It is useful in calculating the force. It is useful to find out how much stuff is moving and how fast it moves. Momentum of an object is defined as the product of its mass and its velocity.
तो clear momentum is mass into velocity, where momentum is denoted by p and it is equal to mv.
Physical quantities are of two types. They are scalar and vector.
Physical quantities are of two types, scalar and vector. Scalar has magnitude associated with it and vector has magnitude and direction both associated with it. You people know what is momentum? आप सबको पता है momentum क्या है? स्केलर क्वांटिटी है या फिर वेक्टर क्वांटिटी है क्लास?
In carrom, a game in which a striker is used to hit and move other coins, a carrom board coin moves 10 centimeters when it is knocked by the striker coin. Scalar quantity depends on magnitude only and does not depend on direction. A striker coin moves 10 centimeters northwards and bounces 10 centimeters southwards. The net displacement is 0, though the total distance covered is 20 centimeters. Vector quantity depends on both magnitude and direction. Example, displacement. Velocity is the rate of displacement of an object. Therefore, velocity has magnitude and direction. It is a vector quantity. Similarly, momentum is also a vector quantity. It has magnitude and direction.
Momentum is a vector quantity because it has magnitude and direction associated with it.
It has the same direction as that of velocity. Its SI unit can be derived as shown here. The SI unit of momentum is kilogram meter per second. Let's consider a truck and a bicycle moving down the street at the same speed. Which will have greater momentum? The truck will have greater momentum because of its size. Let's consider the same example. Now, the truck is at rest and the cycle is moving. Which will have greater momentum? The cycle has greater momentum because when there is no motion, the momentum is 0. Hence, the truck has 0 momentum.
See, is it clear to you? यहाँ पे देखते हैं एक बार दोबारा आप लोग.
Now, the cycle has greater momentum because when there is no motion, the momentum is 0.
जब कोई मोशन नहीं होता तो मोमेंटम क्या होगा क्लास? 0. When there is no motion, there will be 0 momentum.
Hence, the truck has 0 momentum. The momentum of the ball is 8 kilogram meter per second. Have we expressed the momentum correctly? No. Momentum is a vector quantity. It has the same direction as the velocity of the ball. Therefore, we should mention direction as well.
Is it clear? Momentum has magnitude and direction associated with it. If we will write only this 8 kilogram meter per second, it will be incorrect to write as momentum has direction associated with it. We should mention the direction. Suppose here it is mentioned eastward. Is it clear? So this is the correct way to represent momentum.
Bird strikes on aeroplanes usually occur at lower altitudes during takeoff or landing. Though the size of the bird is less than that of the aircraft, it can cause a lot of damage to it because of the greater velocity of the aeroplane. Many airports have bird management initiatives to chase birds away from the airport. Most of the aircraft aircrafts are subjected to bird strike tests as well for protection. Sandblasting equipment is another application of momentum. Applying sand at low pressure on a rusted metal component will not affect it. But when the sand is applied to the rusted metal component at high pressure, it removes the rust and heavy skinners and makes the clean, bare metal visible. This is known as sandblasting. Car bumpers are made of lightweight, high-impact resistant plasters to reduce the collision impact in the event of an accident. This prevents a direct hit on the metal components. High-impact resistant plasters to reduce the collision impact in the event of an accident. This prevents a direct hit on the metal components.
So class, what is the question? The mass of sand particles is small, yet they clean, rust and scales when they are applied at high pressure on an old sheet metal component. Why? Answer is, at high pressure, sand particles hit the surface of the metal at high velocity. When velocity increases, momentum increases. High momentum of sand particles clean the metal surface. Velocity और momentum क्या है? Directly proportional है. Momentum increase हो रहा है, velocity increase हो रहा है. So now it is clear to you. Momentum is mass in motion. Mass into velocity is momentum. SI unit kilogram meter per second. It is a vector quantity, and their applications of momentum are given. That is bird strike management, sandblasting, and car bumpers. These all are the applications of momentum. Is it clear to you, class? So class, with this your chapter ends. We will one time look at summary of the chapter. What is force? A pull or push action on an object is defined as force. It is interaction between bodies or between a body and its environment. Then comes resultant force. When two or more forces act on an object in opposite direction, resultant forces. Difference between the two in the same direction, resultant forces. Addition between the two and in opposite directions with equal magnitudes, the resultant forces F1 minus F2 is 0. And what are the effect of force? Force can move a stationary object, change an object's speed and direction of motion, bring a moving object to rest, and it can change the shape and size of an object. Is it clear? Definition, resultant force and effects. Next is force is push or a pull. Push में it is categorized into two categories, balanced and unbalanced, and pull is also in balanced and unbalanced. Is it clear? Balanced में net force is 0, unbalanced में net force is not equal to 0. And calculation of net force will be, if forces are in same direction, it will combine by addition, and if forces are in opposite direction, it will combine by subtraction. Is it clear? Next is Newton's second law. The rate of change of momentum of an object is directly proportional to the applied unbalanced force and takes place in the direction of the force. हमें पता है क्या होता है, F equals to ma, ठीक है, F equals to ma, जहाँ से क्या पता चला that acceleration is directly proportional to force and it is inversely proportional to the mass of the object. Momentum is mass into velocity and momentum changes over time. Is it clear? Then is Newton's third law of motion, which states that every action has an equal and opposite reaction. The forces should act on different objects. Is it clear? Examples are firing of gun, walking, launching of rocket, getting off a boat. These all examples you have seen. Is it clear to you, class? So with this, your ends. I have sent the PDF of question answers that are in your NCERT books. Now your duty is to read the chapter once again, do the question answers, practice the numericals that are given in your books so that the chapter will be clear to you. Is it fine, class? तो आप लोगों की अब ड्यूटी ये है कि आपने चैप्टर पढ़ना है, जितने भी एग्जाम्पल्स दे रखे हैं आपके एनसीईआरटी में सॉल्व, आपने उनको प्रैक्टिस करना है, टेक्सचुअल क्वेश्चंस करने हैं. इज इट क्लियर? सारे क्वेश्चंस की अच्छे से प्रैक्टिस करनी है और सारी टर्म्स आपको क्लियर होनी चाहिए. न्यूटन्स फर्स्ट लॉ ऑफ मोशन क्या होता है, सेकंड लॉ ऑफ मोशन क्या होता है, थर्ड लॉ ऑफ मोशन क्या होता है, कंजर्वेशन ऑफ मोमेंटम क्या होता है, ठीक है. और उसके बाद